Okay, triple integrals and cylindrical coordinates. We only have a few examples of this because each of these, like, it's split. This section is technically split into two parts, two different types of triple integrals, and we just do a few of each. But we're gonna keep this all in one video, just one section, like half split it into two parts. So first off, just evaluate without much. You're given 0 to 2 pi, 0, 1, and r to square root of 2 minus r squared. So that's in terms of z. So z equals r, z equals square root of 2 minus r squared. You have then r dr, so r equals 0, r equals 1, and d theta, so theta equals 0, theta equals 2 pi. What our limits are. And in general. So when we're solving this, let's continue on. First you have, like before, so it's in terms of z first, so r is just a constant in this one integral. Treated like one. So r times square root of 2 minus r squared minus r, subtraction of 2 minutes. dr d theta, so it's r, so you multiply into r, so it's r square root of 2 minus r squared minus r squared. dr d theta. And now we have to do some work to integrate, just to get it down simplified. At least the last step won't be too long, but this second is this middle integral is integral. So u equals 2 minus r squared, u substitution. I split up into two little integrals, so r squared dr is going to be easy to evaluate. That's just r cubed over 3, and then put in the limits. Yeah, not even just once, let's just keep it. So you do use substitution, you can cancel out the r in front, so it's just in terms of u. U equals 2 minus 1 squared and 2 minus 0 squared, so it's 1 and 2 is what our limits are for that. So you get integral u equals 2, u equals 1, r square root of u, du over negative 2r. And that's minus r cubed over 3, that's how I take it right away. You go down with the red, and eventually you'll get negative 2 plus 2 square root of 2, 3 you could do. Yeah. That's basically what you'll get from this whole thing. So the integral becomes just 0 to 2 pi, and it's negative 2 plus 2 square root of 2 divided by 3 d theta. D theta is going to be very easy. And I think in general, like, this is one of those things that, not in general, it's commonly observed. The last integrand is going to be pretty easy in a lot of cases. In these types of integrals. Especially in this one, it's basically theta equals 2 pi, theta equals 0 times that. So just 2 pi times this whole thing. You can write it as this one. Eventually you get 4 pi times square root of 2 minus 1 divided by 3, all divided by 3. Okay, one more of these just pure ones. That should be theta over 2 pi. So its lower limits are all zeros. It's dz, r dr, and d theta. So it's 2 pi, theta over 2 pi, and z equals 3 plus 24r squared. Okay. First step is just doing the multiply r in. 24r cubed plus 3r dr d theta. Okay, now r is relatively easy to integrate. So we have to do a lot of simplification stuff. You can read it at your own. Cancellations occur here and there, doing it all by hand. So eventually we do get the case where we get 12 pi over 5 plus pi, and then that just becomes 12 pi over 5 plus 5 pi over 5. So that's equivalent. Multiply 5 over 5 by pi. Then eventually you get 17 pi over 5. So 17 pi over 5 is 5 over 5 is the answer. So now for these next two, we just set up the iterated integral for evaluating this type of function. So we have a region of integrate, the region D. It's a function r z dz r dr d theta. Really, this is just setting up to take the volume. We don't actually take the volume. So just some word problems here. So D is the right circular cylinder whose base is the circle r equals 2 sine theta in the xy plane, and whose top lies in the plane z equals 4 minus y. So base is circle in xy plane. That's one way to tell that z equals 0 here. So to sketch out or have a sketch provided. Z equals 0 is lower limit. Because you have its circle in the xy plane. And that's where z will equal 0 in the xy plane. Remember? You see, everything in this course builds up and works together in one way or another. Just not as great as you send some of it. It works out. That's the first step. So we have r equals 2 sine theta, z equals 4 minus y. So z equals 4 minus y is in the upper limit. But we write this as z equals 4 minus r sine theta because we have y equals r sine theta as the conversion. So we have to write it using the cylindrical coordinates, which is in terms of r, theta, and z. R equals 2 sine theta times r on both sides implies so that r squared equals 2r sine theta, which means that x squared plus y squared, because we change it, we can convert it to that, equals 2y. It's r sine theta is y, r squared is x squared plus y squared. And we can add, so we can convert this further, because we want to see what type of circle it is to get an idea. Really had to. I mean, technically you could use a graphing calculator. It's probably still suggested to do that instead. But r equals 2 sine theta, you either use your graphing calculator or you kind of figure it out this way. Graph it in the xy plane. So you add 1 and you get, so we have x squared plus y squared, you subtract 2y and add 1 to both sides. So it would be minus 2y equals 0, but we added 1 to both sides. We simplify this further, x squared plus the y minus 1 squared equals 1. So it's a circle of radius 1, but it's centered at 0, 1. Because x minus 0 squared plus y minus 1 squared. So 0, 1. And this matters because then this shows you where like the region will be. What the polar is in. Not polar, it's cylindrical coordinates, but this is kind of like the polar coordinates under 2D is kind of that analog to it. For these types when it's a circular base. So 0 is less than or equal to r, which is less than or equal to 2 sine theta, that's what r can be. And 0 is less than or equal to theta, less than or equal to pi, because it's the first two quadrants, so 0 to pi. So 0 pi, 0 2 sine theta, and 0 to 4 minus r sine theta. And it's dz, r, dr, d theta, this form gives. And you don't actually evaluate it for this one. You need this. So D is the solid right cylinder whose base is the region in the xy plane that lies inside the cardioid r equals 1 plus cosine theta and outside the circle r equals 1, and whose top lies in the plane z equals 4. So base in xy plane, again, I take that to be the clue for z equals 0. And given z equals 4 is top, so 0 less than or equal to z less than or equal to 4. It's very clean. So r equals 1, you can square both sides to get r squared equals 1 squared, so r squared equals 1 squared. It implies that x squared plus y squared equals 1. So it's a circle of radius 1, center 0, 0. And r equals 1 plus cosine theta, you can graph these both in a calculator. Graphing calculators, software, whatever. And the region is where it's outside the circle and inside the cardioid, so it's region. So now I'll give you your r values. 1 less than or equal to r less than or equal to 1 plus cosine theta is read from the palm. R equals 1 is equal to 1 plus, so you set them equal to each other, or you can also kind of observe from the graph in this case. You get the value of theta that it takes. But set them equal to, so you get 1 equals 1 plus cosine theta, that means 1 plus cosine theta minus 1 equals 0, so it's cosine theta equals 0. It means theta equals pi halves, negative pi halves. Because that's when cosine theta equals 0 is when you can take the inverse, but either way. The cosine inverse of 0 is pi halves or negative pi halves. So there are two values it can take. So negative pi halves less than or equal to theta less than or equal to pi halves. And you can see that you can easily see this in the picture, especially when you feel that those are points of, that's like the point of intersection for it. The two shapes, the two graphs. So negative pi halves to pi halves, 1 to 1 plus cosine theta, and 0 to 4, this function, dz, dr, dr, d theta. Okay, final, just one quick one where you actually are given a sketch with the functions labeled on it. And this is not as good as in the book, but we'll just go with it. So positive x, negative y means fourth quadrant, you can observe. Z equals negative y squared. It's in the xy plane from this, so it's 0 to negative y, via z guys. R equals 3 cosine theta, so it's 0 less than or equal to r less than or equal to 3 cosine theta. You just have to edit negative y to be in the proper coordinates, so it's just r sine theta, y equals r sine theta, so it's negative r sine theta. Yeah, but we have to evaluate this, define volume. So dz, r, dr, d theta is just volume integrands. That's what dv becomes, is dz, r, dr, d theta. V equals, then you have the integrals. 3 pi halves to 2 pi is the fourth quadrant. We have negative y values but positive x values. 0 to 3 cosine pi. 0 to 3 cosine pi. It's just your r equals 0, r equals pi, 3 cosine pi theta. And finally, z equals 0 to z equals negative r sine theta. So we first do that. We get negative r sine theta r times r dr d theta. So negative r squared sine theta dr d theta. We just integrate that, so it's negative r squared is integrated, sine theta can be left out. So you get negative r cubed over 3 times, take the integrand, so it's 3 cosine theta and 0. It'll just be negative, and then in parentheses 3 cosine theta cubed divided by 3 times sine theta. So you get negative 27 because that's 3's cubed, and the negative out front always goes 1. So negative 27 cosine cubed theta sine theta divided by 3 theta. And that can be simplified down to just negative 9 cosine cubed theta sine theta d theta. And the final step is solving this. So between 3 pi halves and 2 pi, this has to be integrated. And you can rewrite this as negative 9 cosine theta alone cubed, just that whole thing cubed, sine theta. And u equals cosine theta means that du equals negative sine theta, so we're going to cancel out because d theta equals du over negative sine theta. And you get your integrand, your new integral limits, 0 and 1. Because cosine 3 halves pi, 3 pi halves is 0, and cosine of 2 pi is 1. So between 0 and 1 it's integrated, negative 9u cubed sine theta du divided by negative sine theta becomes just positive 9 out front, is negative negative. It's negative 9 divided by negative 1, which is positive 9. So u cubed du becomes u to the 4th divided by 4, plug it in. You get 1 over 4 times 9, which is positive, emphasize again. So it's 9/4. So volume is 9/4 for this. And that's it for these types of problems with cylindrical coordinates.